this is my project. We're looking at laser and acoustic sonic net deterrents. And yeah, I'm really excited that you guys tuned in. When we started this project, the whole purpose was to equip farmers and to inform them what deterrents will help them be more productive and sustainable. So thanks for tuning in. And so I will get to sharing my presentation. Okay, and then like I said, my name's Grace. This is Joe on the screen here, my advisor, Dr. Joe Gherkin, and we will be happy to answer any questions that you guys have after this presentation. All right, so before I get started, I just want to acknowledge all the different folks that were a part of this project. All of the hatcheries that we worked at, so Michigan Wholesale Walleye, Ozark Fisheries, Kansas Department of Wildlife and Parks at Milford Hatchery. Just thank you to them for letting us be out there and testing our deterrents. My undergraduate research assistant, Victoria Pfeiffer, we were out there at some weird hours and she was happy to do all the work, so appreciate her. My advisor, Dr. Joe Gherkin, and all of his help with this project. Purdue University, Amy Shambach, Stuart Carlton, Lake Superior State with Jason Garvin. Appreciate all of their efforts in making this project possible. The USDA with our artificial intelligence model that we developed, Kansas State University for their support, and finally the North Central Regional Aquaculture Center for funding this research. And so before I get into my project, I think it's important to kind of take a step back and understand why, we may see bird predation at your fish farms. And this paper by Ellis et al. From 2010 really documents land use change over time. So from 1900 to 2000, I want you to just focus on these colors here on this map. You can see really just intensified colors. That means more people, less wild land available for these birds to use. And so they need resources. And of course, fish farms offer a really, really good place for them to forage. And this paper right here, Yang and Hu, they talk about all these different effects that it could have on animal populations. But what we're going to focus on today and what's relevant to you all at your fish farms is this human-wildlife conflict. Because, these birds, they're hungry, they want to get these fish, but you all need to make a living and make a profit. And so, finding a way to mitigate that is really important. And so here we go. This is to the normal person, this may look like just a fish doing what it does, but to fish farmers, this is a big problem. The literature says that birds can forage 30 to 95% of fish stocks. I'm sure you all have a percentage in your head of what you think you're losing at your farm. But it can be substantial, and depending on migration and all of that. But what we're going to focus on today are these great blue herons, and yeah. And so you see it costs a lot of money. Every single fish has a value that you're losing there, and also time spent trying to get rid of these birds. Just a lot of effort overall. And so I'm going to talk a little bit about different deterrent methods that you may use. So there's lethal methods. These birds are protected under the Migratory Bird Treaty Act, so it makes it very difficult to manage them. Of course, you have to apply for a depredation permit, and very limited in how many birds you can take. And even if you could take all of the birds, the literature shows it may not be enough to actually help mitigate bird predation. And so there are some non-lethal deterrents that you may use. On the top there's some physical barriers. You may cover your raceways with these exclusionary devices. And those, for the most part, as you may know, are pretty good. You may have some problem individuals that can sneak in there and get your fish, but for the most part are pretty exclusionary. You can see that top pond over there. That's a lot of effort that a lot of farmers probably aren't willing to do, but they've strung up all these strings to scare the birds away. But you can see it's really difficult to cover your ponds with a physical barrier. So you may use some scaring devices like this gas cannon on the bottom there to emit a loud sound to scare them away, or have some effigies and some scary looking bird things nearby your ponds. But as you know, the problem is these birds are really, really smart. They can either get in these physical barriers or they get habituated to these scaring devices. And so that's where our study comes in. We wanted to test this new emerging technology. This laser here is from Bird Control Group, and it is fully automated. So you plug it in and it runs 24/7. And the thing about this laser that's also unique is that you can actually control it from your phone. You can tell it the problem areas that you want to target, and then hopefully the birds will not get used to that because it's random. And so that's kind of the science behind the laser. And the dispersal range, so the testing sites that we were at, they were about 6 acres total. And you can see the laser dispersal range. It really changes with ambient light levels. So if you have high, a lot of sun shining, the laser may not reach as far, but at night, its range really increases. So we made sure that one laser was good enough to cover 6 acres. It can cover more. And we also had this acoustic sonic net. This is from Guardian Technologies Group. And basically, the idea with the acoustic sonic net is that it emits frequencies that birds communicate in. And a big part of animal communication is to warn off predators. But these frequencies basically jam their ability to do that, and so they get scared. And the idea is that if a heron lands, they hear this sound, they can't talk to each other, and then they will want to leave. And as far as how far this covers, is like area, it really kind of depends on the wind. So if you have a really windy farm, it may not reach as far. And also topography, if you have very hilly areas, that may limit its reach. But it can, according to the website, reach around 10 acres. And for our study, we used 2 to cover 6 acres, just to make sure we sufficiently covered these fish farms. And so we set up both of these deterrents at 3 different locations in the Midwest. We just wanted to make sure we got a large spread and sample of the Midwest. So we went to Milford Hatchery in Kansas, Ozark Fisheries in Missouri, and the Michigan Wholesale Walleye in Michigan. And you can see all of these fish farms, they have a diverse group of fish that they raise, but they all dealt with predation from the great blue heron. And so we wanted to see whether or not these deterrents were effective. With Michigan Wholesale Walleye, we weren't able to collect data there because environmental conditions prevented their farm from being stocked. So today I'm going to present on data from Kansas and data from the Missouri sites. We had 3 treatments that we did. So we did the laser by itself, the acoustic by itself, and then we wanted to see if they were more effective together with our IPM approach, our laser and acoustic together. And each of these treatments lasted 28 days, so around a month. And in between treatments, we had a 7-day rest period to allow the birds to revert back to whatever behavior they were doing. And we had a control site that did not have any deterrents on it, so we wanted to monitor what birds are normally doing. And then we had a study site where we had the deterrents there. So the first data collection, the first method of data collection that we did observations. We did these 2 days before treatments and then 2 days after treatment. So we'd be there 2 days before we turn the laser on, 2 days after. And we took observations in 10-minute periods. So every 10 minutes, we would look up and see what was out there. And we did these for the daytime during the laser and then during the nighttime for the other deterrents. We also did a camera trap survey. So we had a bunch of camera traps, 30 to 40, put around the perimeter of these ponds. They took pictures every 5 minutes all day during the daylight hours. And they were also motion triggered, both daytime and nighttime, to get any activity. And by the end of this study, we used artificial intelligence. We designed our own model, and we analyzed 3 million images. So we used the AI to tell us if there was a great blue heron in that image or not. So getting into our results, do these deterrents work or not? Well, the first thing that we did to determine that was look at our camera trap detections. How did they change over time? And so starting with Kansas on the top here, we have this is our laser deterrent on day 1. That's the first day of deployment, all the way to day 28. That's our last day. And you can see daily great blue heron detections among all the cameras. And this is just a linear regression. It's just a line that's basically fitting the best with the data points. And you can see that R value, that's showing us whether or not the line is increasing or decreasing. For Kansas, it's slightly decreasing, but that P value that you see, it's not significant. P is significant at 0.05 and it's 0.1. So overall for Kansas, the trend is pretty even. It's pretty linear. The trends don't change over time. And we see a very similar thing in Missouri. The trend seems to increase, however, but it's not significant. So the main takeaway from the laser is that the birds are still around. They still want to be there. They just really love those fish. Now, with the acoustic deterrent, very similar story. With Kansas, we have a slightly increase over time, but again, it's not significant. So overall, pretty even, or it just the detections stay the same. In Missouri, that line pretty much can't get any flatter. It's almost a perfect zero, and that p-value is not significant. So that means that the detections do not change over time, and they're just really constant. So the birds seem to, at least as far as their presence at the farms, not be completely altered by the laser or the acoustic. They're still around. Okay, for the IPM, this is our acoustic and laser together. For Kansas, again, it's the same story. We see a little bit more birds towards the end of the study period. You can see those numbers are much higher. But again, detections are very, consistent throughout the study period. And same with Missouri. The birds just don't really do much over time. If the deterrent maybe efficacy decreased over time, we would expect a negative slope, a significant negative slope. But all of the deterrents that we tested, we just saw that it was very, very consistent. So as far as heron abundance, they still seem to be visiting these fish farms. And then this is something that we wanted to look at. So, we saw the daily great blue heron abundances, but we also wanted to see what time of the day were they showing up. And if we're calling this dial activity, if they were changing when they were coming to the fish farms based on the deterrent. And so dial activity, like I said, is over a 24-hour period. You can see this top graph here. It's from 0 to 24 hours. This is just military time. And you can see basically where they were most active. So the solid line is our control study or our control site with our control cameras. And you can see that there's a peak from 6 to 12. So 6 a.m. to 12 p.m. That's when they most likely were going to be at the control site. But then it flips. You can see the study cameras with the dash line. There's a peak around 6 p.m. or 1800. And so there's that difference there. The overlap is showing you how similar the sites are. So if you have a high overlap, that means that the sites are very similar as far as when the birds are showing up. And this overlap, 0.73, is pretty moderate. There are some differences, but pretty similar. In Missouri, we have a lower overlap value of 0.62. And again, we see a similar pattern. Most of the control activity is happening earlier in the day, so in the morning, and then by the afternoon, a lot of that activity is occurring at the study site. And what we think may be going on there, if you remember that visual I showed you with the ambient light, we think that the birds are maybe showing up to feed. They're looking and they see the study site in the morning, but they also see the laser very visibly because it's low light levels outside. So they go to the control site, and then once those light levels get increase throughout the day, they can't see the laser as well maybe, and then they return to the study site. So that's what we think might be going on there with our laser deterrent. With the acoustic deterrent, a little bit of a different story. So again, we have our study and control site. Control site has no deterrents. That overlap is a little bit higher. So in Kansas is 0.77. And you can see in the morning hours, they're pretty similar, but then towards the evening, we have a peak at the control site with activity. So not really sure what's going on there, but overall are very, very similar. And then same thing with Missouri. The overlap is a little bit higher, 0.87. Activity is pretty similar. So the birds are showing up to feed around the same time. So no big differences there for the acoustic deterrent. Now with the IPM deterrent, so this is our acoustic and laser together. For Kansas, we see a similar pattern that we do with the laser by itself. So again, we have a peak in the control site from 6 to 12 p.m. So maybe they see that laser in the morning and want to go to the control site instead of where the laser is. And then as we progress in the evening, there's more activity in the study cams because they maybe can't see the laser as well. So that was a consistent pattern. In Missouri, the overlap was kind of high. It was 0.8, so a little bit more overlap, and then it starts to diverge in the late evening. So not sure why there's a little bit of a difference between Kansas and Missouri. It could be because Missouri is a lot bigger of a farm, and so they have more places to feed. So that's one thing to consider. But in Kansas, we see a similar pattern as we did with the laser deterrent. And what our camera trap results didn't tell us is what our observations do. So this is when we sat in a blind and we're just observing the birds to see what they were doing and how they reacted. So the most interesting thing we saw was when we were looking at the birds when the laser was turned on. So, whereas before with the laser, they were feeding and doing their thing, we turned on the laser, and on the first day, they started doing this. They had their mouths open, they had their wings spread, and they looked all out of sorts. And they weren't feeding. Um, they were going back and forth between attempting to feed, but they were all out of sorts. And this behavior, after doing some digging, is called gular fluttering when he had his mouth open. And basically, he does evaporative cooling in their throat. And you can think of it kind of like your dog panting. It's panting. And I don't know about you, but my dog, whenever there's a thunderstorm or loud fireworks outside, they'll start panting because they're overwhelmed, they're scared. So that's what we believe is going on here with the laser deterrent. They sense it, they think it's a predator, and they freak out a little bit. And similar story with the delta wing. So he had his wings spread open wide. Basically, they're just allowing their feathers and their skin to, get exposed to the air so that they can cool off and calm down. So same thing with the gular fluttering. They're trying to just relax themselves. So we attribute that to the laser. And here's what I saw. I took these pictures, but you can see they have their mouth open, wings spread. One heron was sitting down, which I didn't see any other time. So they were just all out of sorts when we first turned the laser on the first day. And we saw this in both Kansas and Missouri. It was especially prolonged in Kansas. We saw it happen for a long time, about 4 hours. So in summary, the laser, it changed their behavior. We saw that stress behavior potentially decrease activity during the twilight hours because they couldn't see the laser, or they could see the laser better in the twilight hours, so they avoided the study site. But we didn't see a decrease in abundance. And I've done some talking with farmers at Midwestern conferences, and they said the same thing, that there's this change in behavior, but they still seem to be around. With the acoustic, we didn't see that change in behavior. We saw minimal change in dial activity, but no decrease in abundance. And then finally, with the IPM, we didn't see that change in behavior. There was some change in dial activity like we saw in Kansas, but we didn't see a decrease in abundance. So I think, the story here is there's just not really a silver bullet. I think using different methods that you can would be beneficial. But my study shows that the laser could be promising, but it's just really, really difficult. These birds want to be at these fish farms. They want to eat your fish. But hopefully that will, give you some information so that you can better equip your farm to handle this predation. And so we're also looking at other projects. Last summer, I went and I dyed some ponds. So we did some blue aqua shade just to see if it would, block their ability to see the fish. And hopefully the herons won't want to be there because they can't see But one of the things we ran into is you can see the fish are still visible with we did the highest amount of concentration that was recommended on the bottle. And so, maybe in the future we'll look at making those concentrations higher. Maybe we're looking at black pond dye would be better. So it's definitely worth looking into. We don't have results from that yet, but I'm excited to share it when I do. And so that's all I have, and I'd be happy to take any questions that y'all have. Thank you.